let's take a look at this. We're going to take a look at function notation. So our f at x, and then the inverse function for function notation, which is, looks like an f to the power of -1 to x. It's just considered the inverse of a function. All it means is you can almost set a question like this up really easily by just swapping the x and y position. So if you think of f at x as being equal to, or f at x as being the equivalent of y, you could say something like, actually let's write it as f at x. F at x is equal to 2x, which we can kind of get away with changing the notation back to y just for a step. And then what we would do is we'd invert our values. So the x and the y would switch positions. So you'd have x is equal to 2 and then y. So that's anytime we want to invert a function. So that would be the inverse, and we would set it back equal to y. So if we take a look at this question, the question asks us the very first step is to find the inverse of each function, and then to substitute 3 into the original function, and then -3 into the inverse function. So what we'll do is we'll go through a couple of these. We'll start with a here, which is f at x is equal to 4x minus 1. So we'll write it out here. F at x is equal to 4x minus 1. So one of the questions is find the inverse of that. So to find the inverse, what I'm going to do is I'm going to substitute y where f at x is. And we'll highlight the x because these are the values that we're going to invert. We're going to swap the positions of the x and the y. So we'll get x is equal to 4y minus 1. And now what we're going to do is we're going to isolate for y again. So when I bring 1 to the other side, it'll become x plus 1. And then finally, we divide both sides by 4. And we would end up with x plus 1 over 4. We say it's equal to y, but really what we found was the inverse function. We'll say f inverse of f at x is equal to that. So now that we have the inverse, we have one set and another set. The questions ask us to find f at 3, and I think f at -3. That's right. So f of -3. So to do this, the very first one, we're going to take the original f at x. So we have f at 3 is equal to 4. And instead of using the x value, we're going to substitute 3 in, minus 1. This is just simple BEDMAS. We have some multiplication, 12 minus 1. So f at 3 is equal to 11, right? And if this was a set of coordinates, we could make the argument that this is the coordinate 3 and 11. We could plot it on a two-dimensional graph for ourselves. Another one we could look at is the inverse of -3. So we actually take this equation, got an extra equal sign in there I want to get rid of. Let's rewrite this again. So we're going to say the inverse function, and we're going to substitute -3 in. So the inverse function actually has an x to start. All of this is over the value of 4. So when we scroll down, again, this simple BEDMAS, -3 plus 1 is going to give us -2 over 4, which simplifies into -1/2. So when we substitute -3 into the inverse of f at x, we get -1/2. So again, the coordinate of -1/2. Oh, sorry, that wouldn't be the x value. That would be considered like your y value. Be -3 and -1/2. Okay. We'll zoom out a little so we can see this a bit better. So that's working with function notation and the inverse function.